Good day, engineers. So this video is for our sample problem with regards to the concrete crack and uncrack. So simulan natin yung discussion for the sample problem. So the figure shown in SP3-1 is a cross-section at the midspan of a simply supported beam which is reinforced with T diameter 25 mm bars at the bottom. If the concrete compressive strength is 27.6 megapascal and the steel yield strength is 420 megapascal, we are asked to determine the following. So, sabi niya dito, si concrete is normal weight. So, determine natin yung cracking moment of the beam, the compression in the concrete if the allowable maximum moment is 40 kN meter, and the actual stress using the allowable maximum moment in item B. So dito, binigyan niya tayo ng concrete compressive strength. So concrete compressive strength is the F prime C. So sabi niya doon that is 27.6 megapascals. Then, yung steel yield strength naman is 420 megapascals. So, ang unang-una nating gagawin is to determine the cracking moment of the beam. So, syempre, i-disregard muna natin kung ano man yung rebar na nasa ilalim. So, syempre, this is a singly reinforced beam kasi we have a reinforcement lang dun sa tension side niya. So, let's start it by getting the cracking moment. So, for the cracking moment, syempre, ang kailangan lang natin is yung purely concrete part. Kaya from this figure, kinuha lang natin yung concrete part niya. Then, we will proceed to the principle ng statics. We will get the centroid and the moment of inertia of this figure. So, syempre, obviously, kung di natin kakomputin yung centroid, makikita natin na symmetrical yung figure pag hinati natin. So, ibig sabihin, kung symmetrical yan, malamang ang centroid niyan is nasa gitna ng figure. So, ang height ng figure is 500. Therefore, our centroid is at 250 mm from the top and 250 mm at the bottom. So, let's prove that one correct. So, we divide the figure into 5 areas. So, this is area 1, this is area 2, this is 3, this is 4, and this is area 5. So, we will solve the area and the distance from ng centroid niya from the bottom. So, let's say ang axis natin is ito. So, dito natin kukunin, sisimulan yung centroid. So, let's say this is the vertical axis. So, we will get the centroid from the bottom. So, for figure number 1, we have ang area niya is 250 times 100. So, ang area natin is 25,000 mm squared. Next, yung area number 2, which is a quarter circle. So, ibig sabihin, if the circle has a area of pi r squared, so ibig sabihin divided by 4 lang yung area nun. So, that will be pi times the radius is 100 squared divided by 4. So, our area for this one in terms of pi is So this will be 2,500 pi. So this will be in mm squared. Now for the third area, that will be area 3 is equal to the height or the base 100 kasi 100 lang naman to, which is the radius ng quarter circle. So that is 100 times 300. So that will be 30,000. Then for the fourth one, syempre parehas lang sila nung second area. So area 4 is equal to 2,500 pi. That is also in mm squared. And yung fifth area will be the same as the first area. So area 5 is equal to 25 times 10 cube mm squared. So, yan ngayon yung mga eras natin. Ngayon, ang hahanapin na natin is yung distances ng centroids niya from the bottom. So, kunin natin yung y1. So, ang centroid niyan kasi is nasa gitna, then papunta tayo dun sa baba. So, that will be y sub 1. So, ngayon, that is, syempre, kalahati ng 150 plus 300 plus 100. So, yun yung distance niya. So, that is 50 plus 300 plus 100. So, that is 450 mm. Then, we'll get y sub 2. So, ang centroid ng quarter circle, for example, yung quarter circle, tapos ito yung axis na hanapan mo sa bottom niya. So, sabi dun sa statics, that is 4r over 3 pi. So, that will be 4 times the radius 100 divided by 3 pi. So, that will be, nandito ka pa lang. Siyempre, kailangan mo siyang papuntahin dito sa axis na to. So, i-add natin si 300 and si 100. So, that is 4 times 100 divided by 3 pi plus 300 plus 100. So, that will be 442.4413. That is in mm. So, the next one will be yung 3, yung third area. So, y3. So, syempre, kalahati ng 300 plus 100 na lang yun. Kasi this is the y sub 3. So, kunin natin. So, that is 150 plus 100. So, that is 250 mm. Then, y sub 4 is equal to, so, syempre, nakabaliktad siya na quarter circle. So, kung ang height niya, is 100, so, syempre, ibabawas na lang natin doon si 4r over 3 pi. Kasi nandito yung centroid niyan. So, this is y sub 4. So, 100 minus 4r over 3 pi. So, y sub 4 is equal to 100 minus 4 times 100 over 3 pi. So, that will be 57.5587. Which is in mm. Then, yung y5 is kalahati lang ng 100, which is 50 mm. Now, getting the centroid, we will use the Brightness Theorem. So, that will be area total or the y bar from the bottom, or let's say y bottom na lang, will just be equivalent to the summation ng A1 or A and y divided by the area total. So, yun yung gagawin natin. So, that will be is equal to 25,000 times 450 plus 2,500 pi times 442.4413 plus 30,000 times 250 plus 2,500 pi times 57.5587. So next will be 25,000 times 50. So divide natin to by the area total. This will be divided by 25,000 plus 2,500 pi plus 30,000 plus 2,500 pi plus 25,000. So our y bottom will be equivalent to, so ngayon napalabas natin siya na 250 mm. So ibig sabihin, since symmetrical siya, tama lang na kunin natin siya sa gitna. Kasi symmetrical naman siya. So after getting the centroid, syempre, we will proceed in getting the gross moment of inertia of the concrete section. So, bago yun, syempre, derive muna natin yung equation ng inertia for a quarter circle. So, syempre, ang kailangan kasi natin dito is centroidal moment of inertia. Yung given kasi natin, or yung alam nyo na, na moment of inertia ng quarter circle, yung pi r4 over 16, hindi siya centroidal. That is along the x-axis. So, sa x-axis niya yun, which is dito. So, kailangan i-transfer natin siya papunta dun sa centroidal. So, ibig sabihin, gagamitin natin yung equation ng transfer formula, which is I x is equal to I bar x plus AD squared. So, syempre meron tayo, this is IX. So, ang kukunin na lang natin is A and D squared. So, meron na din naman tayo niyan. So, IX is yung pi r4 over 16. So, lagay na natin. That is pi r4 divided by 16. That is equal to I bar x plus yung area is syempre yung pi r squared divided by 4. Tapos yung yung distance to the centroid or dun sa pagtatransferan is 4r over 3 pi squared. So, i-arrange natin yung equation. So, syempre, yung hinahanap natin yung I bar x. So, that is equal to pi r4 over 16 minus yung pi r squared over 4 times 4r over 3 pi squared. So, ngayon, yung I bar x natin, pag sinimplify yan, will be, so that is 0.05488 r raised to 4. So, yan yung gagamitin nating inertia or centroidal inertia for a quarter circle. So, simulan na natin yung pagkuha ng moment of inertia niya. So, kunin ko lang ulit yung figure kanina. Natin dito. So, ang una nating sabay-sabay na nating kunin para makuha natin agad yung centroidal or gross moment of inertia. So, sa area 1 muna tayo. So, for our area 1, that is a rectangle. So, that will correspond to BH cube over 12. So, that is 250 times 100 cube over 12. So, syempre, plus yung AD squared natin. So, yung area niya kanina is 25,000. So, tayo plus 25,000 times d squared. So, yung distance niya from the centroid of our figure. So, dito, kakailanganin natin yung y bottom na 250. So, since that is also equal dun sa y top, so, that is yung 250 sa y top, ibabawas natin yung centroid nito, which is 50. So, that is 250 minus 50. This is squared. Punta tayo dun sa second area. Sa second area, quarter circle. So, that is plus. So, ang centroid or centroidal moment of inertia will be 0.05488 raised times 100 raised to 4 plus yung AD squared. So, area niya 2,500 pi times yung distance nung centroid niya dun sa centroid ng buong figure. So, kung ito yun, ayan, ibig sabihin, ang distance niya is yung, since ito 250 to, so, ibig sabihin, may 150 ka kasi dito. So, i-add na lang natin si 4r over 3 pi. So, that will be 150 plus 4 times 100 over 3 pi. So, syempre, huwag natin kakalimutan si squared. Tapos, dawa tayo dun sa area 3. Si area 3 plus yung area 3 natin is yung centroid niya. So, yung centroid niya dumaan din dun sa centroid ng figure. So, ibig sabihin, wala tayong kailangang i-transfer. So, that will be inertia lang ng centroid niya. So, that is B will be 100 times 300 cube over 12. So, yun lang. Then, punta tayo sa fourth area. Sa fourth area naman, so, kakailanganin natin si y bottom. So, si y bottom, ito. So, syempre, since y bottom yan, tapos ang centroid niyan, ito. So, ang gawin na lang din natin is, ito yung 150, i-add natin si 4r over 3 pi. So, punta muna tayo ng centroidal inertia niya. So, that is 0.05488 times 100 raised to 4 plus 2,500 pi times 150 plus 4 times 100 over 3 pi squared. So, check natin kung na-squared yun kanina. So, may squared naman. Then, last area will be yung fifth area na rectangle. So, plus 100 times yung base pala, sorry, that is 250 times 100 cube divided by 12. Transfer will be plus, so since y bottom is 250 din, so yung area niya din is 25,000. So the transfer will be 250 minus 50 squared. So yung inertia natin ngayon will be equivalent to 2859.3661. So that is times 10 raised to 6 mm/4. So para madalian kayo sa pagkuha ng inertia kapag ganito kahaba yung equation, store nyo or utilize natin yung store sa calcu nyo. Store nyo to sa A, store nyo to sa B, tapos store nyo to sa C, ito sa D, then ito sa E. So, gamitin natin or utilize natin yung paggamit ng shift store. So, meron na tayong inertia ngayon. So, ang kailangan na lang natin is yung cracking moment. So, we can proceed to our cracking moment na. So, for our cracking moment, kailanganin natin doon yung MCR. So, syempre, kunin natin siya doon sa NSCP probation for that one. So, kailangan natin yung FRIG over D YT. So, that is frig over YT. So, that is, kailangan natin ngayon yung FR pa. Kasi meron na tayong IG, meron na tayong YT. So, FR, sabi sa code, that is 0.62 lambda square root ng F prime C. So, yung lambda natin, automatically, that is 1.0 kasi sabi sa problem, so sa problem natin, normal weight. The concrete is normal weight. So, ito siya. The concrete is normal weight. So, ibig sabihin, kailangan lang natin na 1.0 siya. So, pag hindi rin in-state sa problem, automatically, we assume na normal weight yung concrete nun. Pero pag stated, yung percentage ng aggregates na normal to the total volume of specific aggregate, so, kailangan mong gamitin yung ibang provisions ng NSCP. And hindi pwede yung 1.0 automatic doon. So, si F prime C natin, sabi niya that is 27.6. So, we have to compute FR, which is 0.62 times 1.0 times square root ng 27.6. Now, it will give us the value. So, that will be 3.2572. That is in megapascals. So, yan ngayon yung modulus of rupture natin. So, we are now ready to compute for the cracking moment. So, our cracking moment will be equivalent to 3.2572 megapascals. Then, yung inertia natin will be 2.859.3661 times 10 raised to 6 divided by our YT. Yung YT natin, yung Y bottom, kasi nandito sa baba yung tension side. Nandun kanina yung rebar natin, as you can see from the given. Ito. So, ngayon, ilagay natin yung YT, which is 250 mm. Check natin yung units. This is Newton per mm squared. Tas this is in mm fourth. Kasing nasa baba is in mm. So, as you can see, ang lalabas is Newton mm. So, since Newton mm yan, kailangan natin yan i-convert into kilonewton meter. So, ibig sabihin, we need a 1,000 squared dito sa baba. Kasi 1,000 squared, that is 1 times 10 raised to 6. So, we can cancel this one, and we can also cancel yung times 10 raised to 6 dun sa inertia. So, typing this one dun sa calculator natin, we will have, so that is 37.2541 kilonewton meter. So, ito na ngayon yung hinahanap nating cracking moment. So, we will continue to solve items number 2 and number 3 on our next video. So, this again Engineer Rodolfo, and thank you for watching. Don't forget to subscribe to Butch TV.